In 2021, off the coast of Japan's Suruga Bay, the Japan Agency for Marine Earth Science and Technology captured footage of something extraordinary at a depth of 2,091 meters, the elusive creature of legend, the dream shark. For centuries, tales of this enigmatic being had drifted through fishing villages along the Aizu coast. Fishermen spoke of a mysterious shark that appeared only in the fiercest storms, calming the seas with its haunting song, easing the fears of sailors, and even bringing tears to the eyes of seasoned captains. For years, experts speculated that these dream sharks might be unknown deep-sea creatures. Sharks, after all, are well suited to life in the ocean depths. Unlike bony fish, their cartilage-based skeletons withstand immense pressure, making them ideal inhabitants of crushing depths. This theory inspired Japanese marine scientists in the 1980s to investigate the waters near Aizu, south of Mount Fuji. Beneath these towering peaks lies the Aizu Trench, a volatile geological sibling to Fuji, shaped by the collision of the Philippine and Eurasian tectonic plates. Here, the ocean plunges from the rich waters of Suruga Bay into the yawning chasm of the Suruga Trench, a fault line both calm and violently active beneath the surface. This dramatic landscape fueled the fishermen's tales. In 2013, Japanese scientists even produced a documentary, The Kingdom of the Mysterious Deep Sea Shark, revealing 6 species of giant deep-sea sharks in Suruga Bay. Yet none matched the description of the dream shark. Ancient accounts from the Edo period suggested it wasn't a shark at all, but a dream fish, a creature with scales glinting like armor. Unlike sharks, which lack scales, this creature's armored form hinted at something entirely different. Could the dream shark be a massive, bony fish, dwelling where the pressure should make its existence impossible? In the deep sea, where even steel spheres can be crushed at depths as shallow as 200 meters, it seemed unthinkable. Under such pressure, most deep-sea creatures have evolved cartilage or water-filled tissues to survive. Legends of mermaids or intelligent deep-sea beings have always been dismissed as fantasy. After all, such creatures would require complex, bony structures that should collapse under the weight of the water. However, with advancements in submersible technology, researchers managed to place baited cameras deep in the Suruga Trench. At first, they recorded only small fish known as grenadiers. Then, a massive shadow filled the screen. A creature larger than any known deep-sea fish emerged, calmly devouring the bait. Based on the cage's size, the scientists estimated it was over 2 meters long. Could it be true? Could massive bony fish actually survive these depths? Eager to uncover the truth, Japanese scientists scoured the trench for 2 months, until they finally captured a 2.53-meter specimen. It defied all previous assumptions of what could exist in such a hostile environment. With thick bony structures, an enormous head, and scales that shimmered in the darkness, it shattered our understanding of deep-sea life. They named it Yokozuna Awashi, a tribute to its formidable presence. Yokozuna honors sumo's highest rank, while Awashi means sardine, a symbol of resilience at the food chain's base. The Yokozuna Awashi was a discovery that left scientists with more questions than answers. If such a giant could survive here, what other mysteries might lie deeper, beyond human reach? Less than 5% of the ocean has been explored, with the depths below 2,000 meters remaining almost entirely uncharted. The Yokozuna Awashi might only be the first glimpse of an unseen world. Could the legendary dream shark, or creatures even more fearsome, truly exist? And if so, what does this mean for life in other extreme environments, perhaps even beyond our planet? As NASA turns its gaze from the stars to our oceans, their search for answers continues. After all, the deep sea may hold insights as profound as those found in space, a reminder that some of the universe's greatest mysteries lie right here, hidden beneath the waves. Having ventured into the depths of the Suruga Trench, Japanese scientists set their sights on an even more elusive mystery, the Hadal Zone. This region, named after Hades, lies over 6,000 meters below the surface, where pressures grow so intense that, for centuries, it was deemed a kingdom of death. Down here, not even the simplest life forms were believed capable of survival. At such depths, cells should collapse entirely under the crushing weight. No structure, jellyfish, fish, or otherwise, should endure in this dark realm, and for generations, scientists agreed that these depths were truly barren. But one elderly researcher, a veteran of extreme depths, thought otherwise. There is life below 6 kilometers, he insisted. And his claim wasn't merely based on theory.
Just before we landed on the bottom, we saw a flat fish like a sword or halibut,
he said, sketching out his vision of this deep-sea inhabitant. Few dared to doubt him. By 2010, he was one of only 2 humans on Earth who had descended beyond 6,000 meters, a feat so rare that it, too, had become a kind of legend. The legacy of such deep-sea exploration traced back to another legend, the photograph taken in 1927 of the greatest scientific minds, including Einstein, Lorentz, Planck, and Marie Curie. There, in the back row, stood a tall, lean man, Auguste Piccard, the Swiss physicist known for his peaceful explorations of both the skies and seas. Piccard had already ventured farther than any other in his high-altitude balloon, reaching the stratosphere. His son, Jacques, however, was drawn in the opposite direction, to the deepest oceanic chasms. Inspired by the British Challenger 2's 1950s survey of the Mariana Trench, Jacques envisioned a mission to explore this fathomless abyss over 10,000 meters below the surface, a geological marvel hidden in the Pacific. Jacques went to his father for guidance. Designing a vessel for such a descent was almost unimaginable, considering that at only 200 meters, the pressure could crush a steel ball. But Auguste, a pioneer of high-altitude engineering, believed they could succeed. Deep-sea diving isn't so different from outer space, he told Jacques. Using his stratospheric designs as inspiration, Auguste developed the Trieste, a submersible that looked like a hot air balloon for the sea. Its upper chamber, filled with buoyant gasoline, allowed the craft to float much like a hydrogen balloon, while a spherical steel cockpit provided a tiny haven for the 2 passengers inside. After years of tests in the Mediterranean, the U.S. Navy purchased the Trieste in 1958, hoping it would confirm the Mariana Trench was lifeless, a potential resting place for nuclear waste. At the time, rumors swirled that the U.S. was considering detonating atomic bombs in the trench, hoping the underwater pressure might neutralize radiation or even, some claimed, disrupt Japan's seismic stability. To gauge this hypothesis, they enlisted Jacques Piccard, with Lieutenant Don Walsh as his co-pilot. And it was this very Don Walsh, now a silver-haired elder, who would later insist that life existed at these depths, because he had seen it with his own eyes. On January 23, 1960, Jacques and Walsh embarked on a mission that would rewrite history. Descending to depths that had only been theorized, they encountered sudden challenges. At 9,000 meters, a loud crack split through the Trieste as the pressure fractured a viewport. Most explorers would have aborted, but Jacques, trusting his father's designs, continued. Nearing the bottom, another failure struck as they lost control, plunging the last stretch at an alarming speed. Finally, after 4 hours and 47 minutes, the Trieste touched down on the ocean floor. Through the fractured window, they glimpsed something no scientist could have foreseen: small shrimp, tiny fish, and, remarkably, a flatfish-like creature gliding above the seabed. This discovery shocked the scientific community and, with it, shattered the notion of nuclear waste disposal in the trench. Many dismissed their sighting as a delusion. But in 2017, Japan's Marine Earth Science and Technology Agency deployed drones to these depths, driven by the mystery Walsh and Piccard left behind. They carefully lowered it into the darkness until it finally settled at a dizzying depth of 8,178 meters. The camera, set to activate for an hour every 3 hours to conserve power, offered the team fleeting glimpses into this hidden world. Their patience was soon rewarded when the first footage appeared: a swarm of strange creatures called amphipods, shrimp-like but much larger than their shallow water counterparts. These amphipods measured up to 3 centimeters, an impressive size compared to their Atlantic and Indian Ocean cousins, which rarely grow beyond a single centimeter. The scientists felt a rush of excitement. Had they just encountered the phenomenon of deep-sea gigantism, where creatures grow mysteriously large in the depths? Drawn by the bait, the amphipods clustered around, feasting greedily in a world where food is precious. Yet, as the hours passed, 18 of them, to be exact, no fish had shown up on screen. Disappointment crept in, but then, just as they began to lose hope, the camera captured something startling. "What did we just see?" whispered one scientist, eyes glued to the screen. There it was, a pale pink fish, drifting into view like a ghost from another world. With a body that resembled a massive tadpole, it measured nearly 20 centimeters. Judging by its movements, it wasn't there for the bait. This was a hunter, an apex predator in the depths, and its prey was the amphipods themselves. The team was elated. They had confirmed what was once just theory, that even at such unimaginable depths, life, complex and predatory, thrived. A question lingered. In these pitch-black depths, why hadn't these creatures lost their eyes as cave-dwelling species often do? Though the fish's eyes were small, they were clearly functional. The answer lay in a fascinating quirk of deep-sea life. Many creatures here create their own light. Though sunlight could never penetrate these depths, bioluminescence serves as a language, signals used for hunting, warning, or even courting. In this shadowed world, the deep-sea fish not only survive in darkness but thrive, using light in ways we're only beginning to understand. Eager to study these unique creatures further, the scientists decided to capture some amphipods and, if luck held, a sample of the tadpole fish to examine back on the surface. The amphipods came first. Though nearly muscle-less, their bodies were mostly scales filled with a buoyant, oily fluid. Their exoskeletons, thin but sharp as blades, served as their armor, honed by life under crushing pressure. But what about the fragile-looking tadpole fish? Could this seemingly delicate creature really feast on armored prey? When they carefully brought one of these fish to the surface, they barely had time to examine it. The fish began to dissolve almost instantly, as if melting in the open air. Its delicate sensory organs disintegrated first, slipping through the scientist's fingers. Fortunately, one quick-thinking biologist managed to sketch the organs' arrangement before they were lost. Further scans of another sample revealed something extraordinary: rows of tiny, needle-like teeth lining its mouth, and a second row embedded just behind its skull. This was a formidable predator, evolved to grip prey with jaws that wouldn't let go. Inspired by its fierce nature, they named it the Mariana lionfish, though its soft, squishy form earned it the nickname Mariana snailfish among the team. A deeper mystery remained. Once upon a time, experts believed that life could not exist in the depths of the ocean beyond 6 kilometers. They thought that at such crushing depths, the immense pressure would force water molecules into the proteins of cells, causing them to malfunction and ultimately leading to the death of the cells, and of life itself. This theory held strong until scientists stumbled upon the enigmatic snailfish lurking in the deep. As researchers began to study these extraordinary creatures, they discovered a substance within them that could change everything: trimethylamine N-oxide, TMAO. This miraculous compound seemed to act as a shield, preventing water from infiltrating the proteins, thus protecting the delicate balance of life within these depths. Astonishingly, this very substance is what gives fish their characteristic fishy smell. However, the mystery deepened. While the discovery of snailfish at 8,000 meters was thrilling, it raised questions about even greater depths. The legendary Lieutenant Don Walsh had once claimed to have seen a flatfish at a staggering 10,911 meters in the Mariana Trench. At these depths, the pressure would be immense, likely overwhelming even TMAO, compressing proteins until they became useless. Could any life truly survive at such depths? Determined to uncover the truth, a team of Japanese researchers decided to deploy an advanced underwater robot into the ocean's depths. This robot was equipped with a release mechanism that would send it down to 7,000 meters. Connected by a fiber optic cable, the robot would explore the ocean floor in real time, venturing further into the darkness. As it descended into the eerie quiet of the 10,000-meter mark of the Monahiki Trench, the researchers braced themselves for a desolate landscape where the pressure equaled the weight of a ton resting on half a thumbnail. The question loomed: was there any life here? As the robot explored the abyss, it soon detected movement, a small, white shrimp-like creature scuttling across the ocean floor. Following its path, the team stumbled upon a transparent sea cucumber, its body seemingly adorned with numerous tubular structures. How on earth could these sea cucumbers withstand such relentless pressure? Intrigued, the researchers discovered that these sea cucumbers contained a compound known as silo-inositol, which functioned like a flattened dart, preventing proteins from being squished together under immense pressure. It was a groundbreaking find. As the story unfolded, NASA experts shared their motivations for exploring the deep sea. They had their eyes on 5 celestial bodies, Europa, Ganymede, Titan, Enceladus, and Triton, that were known to harbor subsurface oceans beneath thick ice. In the past, astronomers, heeding biologists' advice, believed that while these icy oceans contained liquid water and geothermal energy, the immense pressure would obliterate protein structures, rendering carbon-based life impossible. But now, they were beginning to see parallels between our deep sea and these distant icy worlds. The discoveries of TMAO and silo-inositol hinted at the possibility of life forms thriving under extreme conditions, even those we once deemed impossible. Could it be that these alien oceans could also give rise to complex, pressure-resistant organisms? Might they evolve into intelligent beings, reminiscent of mermaid legends on Earth? As the scientists pondered this potential, they realized that their view of life beyond our planet was transforming. Slowly but surely, their understanding of deep-sea life was reconstructing their ideas about extraterrestrial possibilities. But caution reigned supreme. Future missions to these alien oceans would need to be approached with great care. They might not just find simple, soft-bodied creatures, they could encounter something far more complex. Yet, one question lingered: what did these deep-sea organisms eat? For years, scientists believed that deep-sea food primarily came from marine snow, organic particles drifting down from the surface like delicate flakes of snow. But as these particles reached depths of 10,000 meters, one couldn't help but wonder, would there be anything left for the inhabitants of the abyss? It felt like a scene from the film The Platform, where the food supply dwindles as it descends through layers, leaving the lowest levels struggling to survive. During their studies of amphipods, the Japanese team made a startling discovery: these creatures possessed powerful enzymes that allowed them to digest wood fragments that had sunk to the ocean floor. This unique diet provided them with energy in a place where few other creatures could thrive. However, wood debris is scarce. Would they have alternative food sources? The team soon turned their attention to deep-sea cold seeps, cracks in the ocean floor that released nutrients from the Earth's interior. Here, they found thriving ecosystems of tube worms and deep-sea corals feeding on these chemical-rich leaks. Could the icy moons of our solar system host similar ecosystems, relying on planetary chemicals for sustenance? In a remarkable twist, researchers discovered a gigantic larvation, a type of marine creature that usually measures just a few millimeters but had grown to impressive sizes in the deep. These giant larvae acted as marine architects, constructing intricate houses from their own secretions, resembling underwater spider webs. These structures were not just beautiful, they captured nutrients floating in the water, filtering enormous volumes of seawater. The largest of these homes could span a meter in diameter and filter up to 100,000 tons of water per hour. Yet, the mystery continued. The larvaceans, despite their remarkable ability to filter nutrients, could not consume everything they collected. So, every few hours, they would abandon their old homes, which would drift down to the ocean floor, becoming a vital food source for deep-sea organisms. The implications of this discovery were staggering. Researchers estimated that just in the Southern Ocean, there were over 10.5 million tons of these larvaceans, suggesting they played a crucial role in the Earth's deep-sea carbon cycle. Were these ancient creatures the planet's unseen architects, cycling carbon and nourishing life in the deep ocean? This led NASA scientists to contemplate whether similar nutrient cycling mechanisms existed in the hidden icy oceans of distant worlds. While these larvaceans did not rely on photosynthesis, could there be analogous biological systems at work in the darkness beneath alien ice? Might there be tiny, unseen machines tirelessly cycling nutrients, providing sustenance for life in ways we have yet to understand? This past July, scientists made an astounding discovery in the depths of the Pacific Ocean: a massive, mysterious planetary battery. The story begins 11 years ago, in 2013, when Professor Andrew Sweetman, a marine scientist from Scotland, was hired by an environmental agency to assess the environmental risks of a seabed mining operation. The mining site lay at the bottom of the Pacific, 4,000 meters deep, where the seafloor was littered with strange polymetallic nodules. These nodules were thought to be composed of shark teeth and microfossils formed over billions of years. They grew at an astonishingly slow rate, only 1 centimeter every million years. However, a preliminary survey in 1981 revealed that these nodules covered nearly 70% of the surveyed area, with an estimated reserve of an incredible 500 billion tons. Were these ancient fossils? The idea was unfathomable, yet they proved to be high-quality ores, prompting mining companies to begin extraction. By 2013, Professor Sweetman and his team were puzzled by one phenomenon: the oxygen levels in these deep-sea mining areas were more than 3 times higher than theoretical predictions. Could there be a malfunction in their sampling equipment? After 10 years of repairs and checks, they found no faults. The only logical conclusion was that these deep-sea nodules were somehow generating oxygen themselves. But without sunlight or photosynthesis, where could this oxygen possibly come from? The leakage of geochemical substances couldn't account for oxygen production. Professor Sweetman was left baffled, leading him to hypothesize that these polymetallic nodules might actually be part of a vast array of planetary batteries. Laboratory measurements showed that the surface of these nodules could generate around 0.95 volts. Although this wasn't enough to electrolyze water into hydrogen and oxygen, which requires about 1.5 volts, the dense array of nodules raised the possibility that they were forming a planetary battery, continuously breaking down seawater to produce dark oxygen. On July 22 of this year, Professor Sweetman published his findings, revealing the second known mechanism of oxygen production after photosynthesis. Could it be that our planet acts like a giant battery, constantly decomposing seawater to create oxygen? If so, could the 5 icy moons with subsurface oceans also possess similar battery structures, providing a steady stream of oxygen for life beneath their ice? Could it be that beneath this abyss lay a high-pressure aquatic world, as speculated by NASA? Perhaps extraterrestrial beings were not in the stars, but in the deep sea, hidden in an alien world that we have yet to comprehend.